Now that we have learned a row level function, we know how to manipulate data, we know how to create new values based on the original data. We have a much more power to utilize the where clause. So here we are going to introduce some more functions of a where clause and try to combine where clause and the functions and select together to form more complex SQL. So let's review what we have learned so far. We use the where clause to identify a subset of data which meets a certain condition or filtering condition. So what the DBMS will do is it will go through each row and apply SQL action on the rows that meet the where clause condition. So the general syntax of a select, of course, is select star from table and where with a filtering condition. This filtering condition can include both the original columns and the computed columns, including the row level functions. Right here, we have an actual tuition times 1.1 greater than something, and you can use certain comparison equations like equals to, not equals to, greater than, greater than. Now you can see here we have two different not equal to. Both are valid. And we have a greater than, and or equal to, less than, or equal to. And let me check this. Let me bring this. So you can see that I have a bunch of SQL statements here, which create the 4 tables and populate with some data. These are used. This will be used in our future where clause demonstrations. So I finished running those and show you some like, for example, select start from registration, where actual tuition times 1 by 1, etc., etc. I run this, and basically because none of them equals to 150, right? So all 4 rows returned. What if I put a 1 equals to 180? There's actually no such thing as 1 equals to 180. It has to be, I believe there's one that is 200. There was 200, so 220 might be the one that returns us. Okay, so this is the fundamental definition of a where clause. Then we have a comparison operators like equals to, not equals to. Note there, here we have 2 different equal to signs. One is this less than and the greater to. This is the original definition of a SQL not equal to operator in SQL. And that's the most common one. And as these years, as more and more people are later on, as more and more people are using C, some people introduce this not equal to C operator into SQL, and a lot of DBMS, including Postgres, also support this not equals to. So you can pick whatever you like and use it. Then we have a greater than, etc., etc. And we also have a logical operator of and or not, right? It's a tuition greater than 500 and sales less than 200. That means both conditions must be met. And we also have an or. If any of a condition is met, then this stands: tuition greater than 500 or sales less than 200. Or we have a not 100 greater than 200. So if anything happens, the tuition, as long as tuition is, for example, for the end, as long as tuition is greater than 500, then this condition, this end both conditions must be met. So it has to be tuition greater than 500, also sales less than 200 in the same row. Otherwise, if any of this doesn't meet, then end will not meet. So tuition, if it's a 499, then the whole condition will not be met, even if sales is less than 200, right? So, and also one thing to note is it's easier to look at the equation, the expression, but when you convert common English into logical operation, there might be a gap when you check whether it is and or not, or. So in common English, we say, I want to find student in data science department and the computer science department. What I really mean, of course, is not to find a student that is both in data science department and the computer science department. I'm actually looking for students either in data science department or in computer science department. So when you write the SQL, it's actually or, not an and. So this is the issue. This is the common issue when you try to convert English into logical operation. This happens a lot with undergraduate students when they haven't learned enough about discrete mathematics. But I think for graduate student, you guys should be able to handle this well. And of course, when you say this or, which brings up another topic, you don't necessarily always need to write student department equals to this, or if the student department equals to that. If we have the same condition, we have a multiple or condition for a column, for the same column, which means if we want to find a column value that is equals to any of the one value in the list, then we can use the in. We have a value list which contains multiple values, and we just want to find any column computation that yields any one of this value. For example, the student department lab the example would be student department in data science, comma, computer science. Or here, where instructor name in Yoda, comma, Obi-Wan Kenobi. And note that because both Yoda and Obi-Wan Kenobi are varchar, so they have a single quote. And because they are separate values, they are not the same one value. So they have to be separated by a comma with both single quote. You cannot have something like this, Yoda, Obi-Wan Kenobi. In that case, SQL will thought you are looking for the whole string of Yoda, Obi-Wan Kenobi, because this is the one separated value, where Yoda is a separate value and Obi-Wan Kenobi is a separate value. When you use an in to pick from any one of this, you have to separate them, each with a single quote and separate with a comma sign. And for continuous data, there's also something called between and, which will just give you a where clause computation between a lower value and the upper value. So for example, here, actual tuition is between 200 and 400. Now, this is straightforward at first glance, but there are two things to note. First of all, it's inclusive of lower bound and upper bound. So if you have a 200 or you have a 400, then these will both be included. And second thing is lower bound must be lower than upper bound. You must start with between 200, then followed by and 400, because 200 is lower than 400. You cannot say between 400 and 200. This will return nothing to you. Okay, so let's take a look at some examples. So we already seen the first thing, the select where tuition equals to. Now, we will check the and sign. Before that, let's run the select star just to see what are the values. The first one we want to see is the tuition greater times 1.1 greater than 150, which will brings up 200, 500, and the 180, right? Now, and the student has to be Luke Skywalker. That means it both has to be met. We have to find all the students with a Luke Skywalker, these three rows, and the tuition times 1.1 greater than 150, which should bring only one value to us. And also, note here we have a tuition of now. Now times anything is still now. So actual tuition times 1.1 will return now, and that means it will not satisfy any where clause condition. It will not show up in any of these comparison results. And let's see if this is the case. That's correct. We have the 180 row, right? Now, what if we want to use an OR? If we use an OR, then it will be still name equals to look Skywalker or actual tuition greater than 150. So when we look at the original data, this should return us all these three rows because student are all look Skywalker and tuition times 1.1 greater than 150. And because these two happens to be both to be greater than 150, so all five should be selected. Right? And what about tuition greater than 150? And not tuition times 1.1 greater than 550. That should also only brings up 50, right? This 50, and note that the now value does not show up either. So how about in? If we run this with Yoda and Obi-Wan Kenobi, we get both instructors, right? But what if I have this Yoda and Obi-Wan Kenobi without single quote, without using single quote to properly separate each value? We're not getting anything because there's no such instructor called Yoda, comma Obi-Wan Kenobi. All right. Okay, so and about between. This will bring us all the values, all the actual tuitions, all the rows where actual tuition between 100 and 200, which is 180 and 200. And there are two things to know. One thing to note is this is 200, right? So which means it's inclusive. 100 and 200. 200 is included. If its a value is 200, it's included. If its value is 100, then it's included. But if I put the actual tuition between 200 and 100 and let 200 come first, what will come? Nothing, because the lower bound should be coming out first. If you have a lower bound first, if you have a higher value first, then there will be an issue in organizing the value, adjusting the value. So this is the issue. And also, as we said it multiple times, the issue, the worst issue of this issue is that there's no error message and you don't see it. So in general, if you run into an error, don't panic, because with a error, SQL error message is not very intuitive, but at least you know there's an issue, right? If there's no issue, you still need to be careful. It could happen when you run the SQL. It's very common for you to run to an error, either a data error or execution error, then trace back and realize that this error actually happened like a 5 or 6 runs of SQL before the error message actually comes up. This is very common. This is not unheard of, at least. So always pay attention to data and don't really trust SQL, even if you were able to run that without error. Don't say I didn't make any mistake just because you didn't run into error, because like we see just now, or even in before, like those equals to now, not equals to now thing. Error can happen when you don't really realize it.